Good afternoon, friends, and welcome back to my channel. In this video, we want to talk about mathematical method, approximation using orthogonal polynomial in particular. Now, why are we studying this? The reason is because if you are asked to approximate a given function, say y is equal to f of x, we try to approximate it in form of a power series. So what do I mean by a form of a power series? Remember that your power series say that, let's say y is equal to the summation of I starting from 0 to infinity of ai x raised to power I, something like this. Okay, sorry, let me use to n. Let me say to n here. And then you see that this is something as what? A naught x raised to power 0 plus a1 x1 plus up to a n x raised to power n. Okay. Now, if you look at it, you see that all these things are all functions of x. So we can put it in this form. We can put it in this form that this is the summation of I starting from 0 to n of a n file of x, a function of x, I, let's use I, then I, okay? So if you look at this, see that this is something as saying a naught file naught of x plus a1 file 1 of x plus dot 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 up to a n file n of x. Okay, so now that is what we and then you should know that then all these functions of x are called orthogonal polynomials. Okay, they are polynomials of x and they are called the orthogonal polynomials. So first of all, you need to know what is orthogonal polynomials before we continue uh, teaching you this. So first of all, what do we mean by orthogonal polynomial? What do we mean by orthogonal polynomial? Okay, right. A polynomial f of x, if you have a polynomial f of x, okay, a polynomial f of x and g of x, okay, are said to be orthogonal with respect to a weight function, w of x, okay, over an interval, say a comma b, if this condition is satisfied. So write for me that a polynomial f of x and g of x, okay, are said to be orthogonal with respect to a weight function w of x, of x over an interval, over a closed interval, okay. In fact, you can call it a closed bounded interval. Hope you know that this a closed interval is bounded. So a closed bounded interval a comma b, if this condition is satisfied, the condition there is that the integral from a to b of that function, okay, multiplied by the other function, multiplied by the weight function. If you multiply all the functions, the two functions with their weight function, with respect to x, you integrate it and then put the boundary that it must give you 0. So we conclude, once this is satisfied, we conclude that f of x and g of x are orthogonal. So let me give you an example to that so that you understand what I mean by that. Okay, example, if we have that, you can say let f of x be equal to x and then g of x be equal to 3 over 2, let's say 3 over 2x, 3 over 2x squared minus 1 over 2. Let's have this, okay? And then over a weight function, let's say that the weight function is 1. And then over an interval, okay, with respect to this weight function y, over an interval minus 1 and 1, okay? So we want to show that this is orthogonal. How do we show that this is orthogonal? We apply the same thing here. The integral from minus 1 to 1 of my f of x is x multiplied by 3 over 2 x squared minus 1 over 2, okay, we have this, then multiply by 1, then the x, okay. So you see that this is equal to the integral from minus 1 to 1 of 3 over 2 x raised to power 3 minus 1 over 2x, okay, then all bracket the x. So if you integrate this, you see that you're going to have the integral will give you 3 over 2 is a constant. So you add 1 to this and divide by the same power, multiply by x raised to power 4 over 4. Okay. Minus 1 over 2 is a constant, multiply by, add 1 to the power here, divide by the new power. So I'm going to have x squared over 2. Then the boundary is from minus 1 to 1. So I'm having that this time this will give you This is 3x raised to the power 4 over 8 minus x raised to the power 2 over 4. You put the boundary 1 and 1 minus 1. So boundary is always the upper bound minus the lower bound. So if you put the upper bound, I have 3 into 1 raised to the power 4 over 8 minus 1 squared over 4. Everything here minus the lower bound 3 into minus 1 raised to the power 4 over 8 minus 1 raised to the power 2 minus 1 raised to the power 2 over 4. Okay, you see that this will give you 3 over 8 minus 1 over 4 minus the same 3 over 8 minus 1 over 4. So when anything subtract each other, I'm having 0. Okay, now even without solving all this from here, you should note that whenever you have the integration from minus a to a, from minus a to a of a function s, okay, with respect to x, that it must give us 0 if that function x is what? Is an odd function. If f of x is what? Is an odd function. Okay, odd function. So what do we mean by an odd function? Don't forget that an odd function say that f of minus x must give you the same thing as minus f of x. That is what we mean by an odd function. But an even function say that f of minus x, now the minus will not come out, the minus will disappear. It must be the same thing as f of x. Okay, and then don't forget that in trigonometry, that it is only cos that is an even function. The rest is what? An odd function. Only cos theta is an even function. The rest is an odd function. So whenever you have the integration from minus a to a of any odd function, you don't even need to do the integration. It must give you 0. If you do it self, it must give you 0. So that means the integral of sine x, as far as I know that the boundary they gave me here is the negative of each other. Maybe from minus 5 to 5, for example. You don't need to do this. The answer must be 0. Okay, so it's a law, one of the laws of integration you should take note of. So now, having known the picture of orthogonality, that a function, two functions are said to be orthogonal when you take the integral from a to b of the two functions with the weight function, with respect to the weight function given, that it will give you 0. So that's what we mean by orthogonality. So the approximation using orthogonality shows that if we can expand that a given function into power series. Now, if we pick any of the two terms of the power series and then multiply it by the weight function, and then we take the integral with the boundary that is given, that it must give us 0. That is why we call it what? Approximation using orthogonality, orthogonal polynomials. Okay. So now, with this said, let us now go to the main thing we are here to do, which is what? The approximation using orthogonal polynomials. So you have understood what we mean by orthogonality or orthogonal polynomials. Okay, so having this, write for me, let f of s be a polynomial we want to approximate. Let's say that this f of x, let y be equal to f of x. This is the function we want to approximate. That means we want to turn this function into y, which is equal to what? Don't forget, which is y, which is equal to the summation of I starting from what? 0 to n of what? ai file I of x, which is taken as saying a naught x, a naught file naught of x plus a1 file 1 of x. It continues that way up to an file n of x. Okay, so having known this, we want to turn this into this, and believe me that if we turn this into this, I'll give you an example. If we pick any two members we like, you can pick these two or this with the next one. If we pick any two members we like, and then we take the integration, we test the orthogonality, it must give us 0 to show that it is what? Orthogonal. So take note of that. So now this is what we want to approximate. Okay, and don't forget that your I is always from 0 to this, which you can write that I is an element of a closed interval of 0 and n, right? A closed interval of 0 and n. Or you say that 0 is less than or equal to I, which is less than or equal to n. So don't forget that. Now, to do this, you should take note that what? That all these functions are called orthogonal polynomials. All these functions we are seeing, all these functions, let me call it file I. In fact, file I of x, and remember that I is what? I is always an element of 0 to n like this, okay? All these things are called what? Orthogonal polynomials. Orthogonal polynomials. Polynomials, okay? And they are known. Yes, once you derive them, you have known them. Yes, so the only problem here is the coefficient of all the polynomials are the problem. So we are going to derive a system that will help us to always get the coefficient of the polynomials. Once we have that, we are done. So that is the next thing we are going to do now. For us to derive all these coefficients, how do we get the value of all these coefficients? That is what we are going to derive now. So follow me, let's do that. I hope I'm not fast. If I'm fast, please, you pardon me and then rewind it. Yes, you can watch it like 5 times so that you understand better. Okay? So now, to get that, the first thing we do is we take the residue function. The residue of the function is given as s. You should know that, please. The residue of the function is given as s of the integral from a to b of the weight function. Okay? The weight function in bracket of f of x minus that your y, like this. F of x minus your y, okay? You take all squared. F of x all squared, the x. Very simple. Very, very simple. Or some people will say small y minus the big Y. And remember that small y is same thing as f of x. So anyone you like, okay? So you should know that this is the residue function. Now, we know this man. Let us put this man and see what is going to happen here. If we put this man, we see that x is equal to the integral from a to b of the weight function into f of x minus, this man is something as saying a naught file naught of x plus a1, okay, let me put them in brackets because of the minus, plus a1 file 1 of x, okay, plus dot dot dot, it continues that way to I can even have ai file I of ai file I of x plus dot 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 plus I will now have an file n of x, which is the last one. Okay, don't forget that if you close this one, then you close the bigger bracket and square it and then put your this x. Okay, so we haven't known this. The next thing we'll look at is how to reduce it. Okay, we have to minimize it. We have to minimize the residue function, okay, or the residue of the function into say the particular one. So let us minimize it into taking each of them. Okay, so let us minimize it. Now to minimize, right, to minimize this residue, okay, to minimize this residue, we say that a particular one, minimize a particular one, we say that it is the s over that particular one you want to minimize, okay, it must be equal to 0. So that is how we minimize it. So remember, and then don't forget that your I is always an element of a closed interval of 0 and n. Don't forget this. So now, to minimize this, so let us do that. And if you differentiate this, if you differentiate each of them with respect to, if you differentiate x with respect to each of them, it will give us 0. So let's take the first one and see how it will look like. The s over the a naught, which means now that a naught now becomes the only independent variable. The rest becomes a constant. Remember that this one here is the dependent variable. So since we say that a naught is on the denominator, so a naught is the only independent variable. And let me show you something. If you want to integrate something like this, if you want to differentiate something like this, maybe 2 minus x squared all raised to power 4. Remember, the way to differentiate this, we want to differentiate this with respect to x. The way to differentiate this is called function of a function. So we have to differentiate the bracket, then differentiate everything. So the shortcut shape, differentiate the bracket, differentiate everything. So if we differentiate this bracket, I'm going to have minus 2x squared. You now multiply, minus 2x. Differentiate this, you are going, this is 0, this is minus 2x. You multiply it by differentiation of something that has power. Means what? You multiply by the power and then you remove one from the power. So that is how to differentiate this. So this is exactly what we are going to do here. This is function of a function. All these things are raised to power 2. So to differentiate it means we differentiate this inside. To differentiate this inside, we give you minus a naught alpha sorry, differentiation of this one is gone. So minus alpha a naught, because this one does not have power. So if it is like this, it's going to be just minus 2. If it is like this, it's going to be just minus 2. Okay, so differentiation of this just give you minus 2. So differentiation of this one will give you minus a naught. So I'll bring out the minus a naught outside, but don't forget that we're still going to multiply by the power and remove one from the power. So I'm having minus 2a naught outside. Okay, I'm having minus 2a naught outside. Okay, is it minus 2a naught? Sorry, a naught is the function minus phi naught of x. Please look at that. See this as the x. See this as your constant. This is a constant. So this is something as saying this is your x. So this is something as saying phi naught of x and the a naught. So this is my x, and this is like that my coefficient. That my coefficient, for example, 2. So the differentiation of these two things is 2. The differentiation of 2x is 2. So the differentiation of these two things is this one. But remember, it has minus. So the differentiation will be minus this thing. So let me bring it outside. So minus this one. Forget about this one, writing it. Minus this is the differentiation of these two people. Okay? So, and remember that these two will come to this part. So I'm putting it here. So the integral of repeating everybody now raised to power 1. So repeating everybody will now be AB. Remember that phi naught is supposed to come outside though with this person, but it is a function, so we are putting it inside there since it's a function. So have phi naught of x, okay, phi naught of x, phi naught of x, then repeat everybody, w of x, then into f of x minus a naught phi, a naught phi naught of x plus a1 phi 1 of x plus plus ai phi I of x plus plus an phi n of x. Okay, so there is no squared now, so I'm going to just have the x. There is no squared. So what we are going to do is, if we continue individually, you will notice that if I do for 1, it will still repeat the same way like this. Look at that. If I do for a1, it's going to be what? If I do for a1, it's going to be differentiate here to give you phi 1 of this. With the minus, it will be minus phi 1 of this. Remember that the 2 will still come. It will be minus 2 phi 1 of this. So it will be minus 2 phi 1 of this, repetition of this. So let us do the I1, the one we want to reduce, the I1. So I have that the S over the AI, okay, this I, that is the one we want to do. So it will take the same pattern. It will now be minus 2 the integral from a to b of phi naught of, phi I now. So phi I of x with function of x into f of x minus a naught alpha naught of x plus a1 alpha 1 of x plus plus ai alpha I of x, okay, plus plus an phi n of x. So don't mind the way I'm calling this thing. I might be missing it. You know that writing this thing, you may be writing something and be saying a different thing. So just take note of what I am writing. Okay. So now, with this said, you know that all these things must be equal to 0. This one will be equal to 0, and this one will be equal to 0. Okay. So you should know that the one we are minimizing. So remember that we want to we need that particular thing that minimizes the residue, and that particular thing that minimizes it is this one. That's what we need. This is the only one we need. The other ones are just each of them. So the main one is this. So this one is what we are going to work with. So permit me to clean so that we'll do that. Remember that what we are trying to derive is just the formula that can help us to be getting all our A's. Okay, so the formula that, so let us write out this. So this one now, with this, you will see that if I divide both sides by 2, this minus 2 can be gone. Because if you divide everything by minus 2 and divide this side by minus 2, 0 divided by minus 2 is 0. So minus 2 can be gone. So if minus 2 is gone, I'll have that this is the integral from a to b of, what is remaining here is phi I of x, w of x then into f of x minus a naught phi naught of x plus dot 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 plus ai phi I of x plus dot 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 plus an phi n of x. Okay, you close again the x. Okay, now there is something I need you to look at. Do you know that what am I saying? Okay, do you know that the integral of a bracket b minus c, maybe the x, is the same thing as saying the integral of ab the x minus the integral of ac the x. So note this. So which means we can just use this to open the bracket and take the integral individually. Okay, so if we do that now, what are we going to have? If we do that, what are we going to have? Can I clean? Okay, let's clean. So let us do that. Having this in mind, you are going to see that this is something as saying the integral from a to b of phi I x weight function. Or let me first of all write the weight function. They are the same thing. So weight function of x, phi I of x, okay, multiply by the first person. So I have multiply by f of x dx, okay, plus this one will multiply by all these people here. So I'm going, minus, because of this minus the integral from a to b, okay, okay, let me write the weight function first. Weight function of x, phi I of x, then into all these people here, which is a naught, phi naught of x, okay, plus dot 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 plus ai phi I of x, okay, plus plus dot 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 plus an phi n of x, okay, then I put my dx, everything dx, okay. Don't forget is equal to 0. So if it's equal to 0, this one can move to the other side. If it moves to the other side, we will now have that this is equal to this, okay. So I'm going to have that the integral from a to b. Don't forget that all these things I wrote are always equal to 0. Please don't forget that if they are equal to 0. So I have that this one moving to the other side. I will have I'm still looking at my mic so that it will not off. So I have the weight function of x, phi I of x, okay, f of x dx, then will now be equal to the integral from a to b of the weight function of x, phi. In fact, I can use this to even multiply each of them, but let me take it gradually. Weight function of phi I, weight function of x into a naught phi naught of x, okay, a naught phi naught of x plus dot 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 plus ai phi I of x plus dot 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 plus an phi n of x, okay, you close. Okay, so now having this, remember we can still apply the same thing. So these people will multiply this, multiply the same one, and so on and so forth. So if we do that, we're going to have, if we do that now, we're going to have, let's open, we're going to have the integral from a to b of w of x, phi I of x, f of x, okay, the x is equal to the integral from a to b. Let's multiply. Everything here will multiply the first one here to have what? Let me have w of x, uh, phi 1 of x, a naught, phi naught of x, plus dot 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 plus. You know the next one to the next one now. The integral from a to b, w of x, phi I of x, then ai phi I of x, okay, the x, sorry, there's supposed to be the x here, the x, okay, so plus dot 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 plus, so the n1 now will now be the integral from from a to b of w of x, okay, file I of x, then I'm having a n file n of x dx, okay. Now there is something I need you to know. Let me remind you the the definition of orthogonality. Remember I said that two functions f of x and g of x, okay, with a weight function, with respect to a weight function w of x over an interval, let's say a and b, is orthogonal uh, if any of these two conditions are satisfied. I gave you one of them, but let me now give you the two of them. The two of them say that the integral from that a to b of f of x, g of x with their weight function, or some people can just write their weight function first. Arrangement does not matter. Their weight function first, then f of x, g of x, dx will now be equal to, it will be 0 if okay, it will be 0 if f is not equal to g, or let me call it, okay, let me call it f1 f2, let me call it fi fj, let me call it like this, fi fj, okay. If I is not equal to j, let me have it this way, then it will now be the integral from a to b of w of x. If they are now equal, if I is equal to j, it's just normal. That is, I is equal to j, it means that here can be I. So this times itself will give you f of x, f squared I of x, or f of x all squared like this, then the x. Okay? It is this when I is equal to j. So the one I gave you initially was when it is 0, provided that these two are not equal. So provided that f of x and g of x is obviously they are not equal. So if they are not equal, you have 0. But if they are equal, you have something like this. So why am I saying this? Look at the reason I'm saying it. Let me leave this one the way it is. The integral from a to b of w of x file I of theta of x, file I of x, f of x dx will be equal to, look at what is going to happen here. These are the two functions I'm looking at. This is just a constant. This is just a constant. These are the two functions I'm looking at. So if I'm looking at these two functions, what is happening here now? We're going to see that, okay? We're going to see that, what's going on here? Okay? Yes, we're going to see that this is I is not equal to 0. This and this are two different things. So here is 0. So if you check the other ones, they are all going to give me 0. The only one that will not give me 0 is this particular one, because I'm having file I and another file I again. So this one is the only one that will not give me 0. So, and that one is what, if you see that this one is going to be 0, this is I and N. So here is equally 0 again. So I'm going to clean. So make sure you write that. You can pause the video and write that. So let me clean and write the one that did not. So the only one that survives among all these things is this one. This one is the only one that survives. So, and if it is survives, the AI is a constant that can come outside here. So if it's a constant, it can come outside. I'm going to have AI coming outside as a constant. I'll have the integral from A to B of what? W of x, file I of x, all squared. All squared. Some people will write it phi squared of x, the same thing, the x. Okay? So now, the main formula we are now looking for is to make this one subject of the formula. So if I make AI subject of the formula, I'm going to have that this is the integral from a to b of w function, w of x, file I of x, okay, f of x, dx, all over the integral from a to b of w of x. Then I'm having, some people write as file squared I of x. dx. Okay, so that is the main thing. So in some textbook, you will not see it as I, you will see it as n. So if I put n, the same thing. If I put n, it will now be an will now be the integral from a to b of the w function of x. Phi. Some people use p or anything. Just phi is a function phi n of x, then f of x. Okay, the x all over the integral from a to b again of w function of x, then phi squared n of x dx. So this is the formula that will help us to be getting our a0, a1, a2, a3, blah 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 to anywhere we want to get that. Okay, so according to the man that taught us, the one he gave us is something like this. He gave us something like this: the integral from a to b of f of x first. He wrote the f of x for, then call this one pn of x, then the weight function of x. Okay, all over. Sorry, all over. Don't forget that there is the x here. The integral from a to b of he gave us pn of x, pn squared of x, then with weight function of x dx. So that's exactly what he gave us. You see that this and this are the same thing. The only thing is that he called his own file p. All we know that they are all function of x. They are the same thing. So if you look at that, you compare, you see that it is the same. So now the next thing we're going to look at is some orthogonal polynomials with their weight function, okay, or properties. We can call it some orthogonal polynomials. Let's look at some orthogonal polynomials. Okay, we're going to solve an example to understand all these derivation. So, but the main thing is just to know this formula. In exam, they may not ask you to derive it. I don't know. If they ask you to derive it, no problem. You have to learn it. It's not difficult to derive, but if not, what we need, they can just give you an example to solve. And what we need is just this thing to get what we want. It's just this thing. So now, all this P of n, Pn of n, or the ones I call phi of n, all of them are the orthogonal polynomials. And it depends on the particular one. We have legendary orthogonal polynomials. We have there are so many of them. We have Chebyshev type 1, Chebyshev type 2. We have Hamid. We have Hamid. There are so many of them. So that's what we want to look at. So these ones depend on the So sorry about that. I knew my mic was going to off, so that's why I was just looking at it to know when it's going to off. Okay, so like I said before, I don't know where the mic got stopped, but like I said before, we have different types of orthogonal polynomials, and the first one we are going to look at is legendary polynomials. And I said that I will subsequently take each of them and do a particular video on that, explaining and deriving so many things about them. Okay, so the first one is legendary polynomial, and the first thing you have to know is its Legendre formula. The Legendre formula for legendary polynomial is given as Pn of x is equal to 1 over 2 raised to power n factorial dn over the Sn of s squared minus 1 raised to power n. What does it mean? This thing means that all this file n, file blah blah blah, we are getting file I or file n, we are getting. So for Legendre, this is the formula that will help us to get file 1, file 2, file 3. But in Legendre, instead of calling it file now, we call it P. That is why I don't want to use P in deriving the formula. I want to use a different thing entirely. So for Legendre, we call it P. So P1, P0, P2. So this is the formula that will help you to get all those P's. So then their coefficient will now, you will now use that last one we derived to get their coefficients. You understand? So this is the first thing you have to know for this. So the next thing you are going to know is the recurrence formula for Legendre. Recurrence relation. The recurrence relation for Legendre is given as n plus 1 p n plus 1 of x is equal to 2n plus 1 x pn of x minus n pn minus 1 of x. Okay, so since we know this, with this we can even if you don't want to use this, if you know this one, you can equally get your p blah 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 of each of them using this recurrence relation. So any of them will give you all your file or p n of x. Okay, any of that will give you that. So that's the first one. So the next thing you should know about is their weight function. The weight function of Legendre, we call it w of x. The weight function of Legendre is 1. Please take note of that. And Legendre has an interval. The interval of Legendre is from -1 to 1. Please note that. That's the interval of Legendre. This is 1, 2, 3, 4. The last one, 5, 1, is the orthogonality of it. Orthogonality. Yeah. Orthogonality of it is given out. Don't forget the formula of orthogonality. The integral from a to b of what? Since it's p now, I'm going to say pn of x multiplied by what? Pm of x. Remember, when they are not the same thing, you multiply by the weight function, that it will give you what? 0. So if you put it now, you're going to see that it will give us the integral from -1 to 1 of pn of x multiplied by pm of x. Okay, multiplied by our weight function is 1. So we're not, okay, sorry, the x. There must be the x because we're integrating with respect to x. So the x is equal to 0. So that is the orthogonality of legendary polynomial. I'm going to still solve questions on legendary, or let me see my time and know what to do. Okay. I don't want this video to be too long. Okay, so that is that. So the next one, do I say the next one, or let me solve an example before the next one? Okay, an example to that. Let's solve an example. Okay, I can clean here. So write this, very, very important. Now, for us to get our P1, P2, P3, and then please note that all these Pn means do I call it the n degree of the polynomial. So if we are looking for degree 1, if it's degree 1, we are supposed to find just P0 and P1. You understand? If you are looking for degree 2, they can tell you to find degree 2 polynomial. You are looking, quadratic. You will look for what? P0, P1, and P2, like that. You understand? So your own will stop at 2. If it is degree 3, depending on the degree they ask you to find. So note that this n is the what? The nth degree of the polynomial. So note that. So let us find maybe few of them Let us find few of them and then know what it will give us. So let's first of all find P naught of X for polynomial. And once you find it, it does not change. Once you find it, it doesn't change. That is it. Anytime you are talking about Legendre, P0 of X is P0 of X. It does not change. That's why I told you that when I wrote that orthogonality, that when I wrote what's it called? That expansion I wrote, I told you that all those files are constant. They don't change. Once you know it, you know it. According to the particular one you're talking about, if it is Legendre, if it is Legendre polynomial or Chebyshev polynomial and the rest of them, so they don't change. So let us find it. So P of X, say anywhere you see n, you put what? 0. So we have what? 1 over 2 raised to power 0, 0 factorial, the 0 over the x 0 of x raised to power 2 minus 1 raised to power 0. Obviously, this is 1 because 2 raised to power 0 is 1, 0 factorial is 1, this raised to power 0 is 1, so differentiation, everything is what? 1 is obvious. So for Legendre, P naught of x is 1. It does not change, is 1. So let us find the second one, P2 of x. P2 of x will give us, P1 of x rather. P1 of x will give us 1 over 2 raised to power 2, 2 raised to power 1. What am I doing? 2 raised to power 1, 1 factorial, d of the x. I hope you know there's 1 here, of x squared minus 1 raised to power 1. So let's see what the answer will give us. The answer will give us 1 over 2. 1 over 2 is here. So the differentiation of this will give you 2x. So 2x. So the differentiation of this one is gone. So 2 cancelling 2, I'm having x. So the P1 of Legendre is x and it does not change. So note that. We are going to use it in our example we are going to solve. So let me write it out somewhere. So we have gotten that our P naught is 1 and our P2 is x. So let us get our P3. So for our P3 of x will now be equal to what? What am I saying? P naught and P1. So let's get our P2. Our P2 is what? 1 over 2 squared, 2 raised to power 2 factorial. Then I have the squared over the x squared of x squared minus 1 squared, right? Okay. So this is something as saying 1 over 4 multiplied by 2 factorial is 2. That is 1 over 8. Here is 1 over 8. So 1 over 8 d squared over the x squared, or rather, let me differentiate d over the x. So let me do the first derivative. The first derivative means multiply by this power, differentiate the inside, to give you 2x. Differentiating something that has power means multiply by the power, remove 1 from the power. So I'm going to have 2 into x squared minus 1. Okay, so I'm having 1 over 8 d over the x of this time. This will give you 4x times this will give you 4x cubed. 4 times this will give you minus 4, right? Okay, so to give you 1 over 8 into differentiation of this will give you 12x squared. 12x squared minus differentiation of this is gone. There is x here. 4 times 1 is 4x. So differentiation of this will just give you 4. Okay, so if you share it, you're having 12 over 8x squared minus 4 over 8. So the final answer will now be, let me write it here. The final answer will now be 4 into 12 is 3. 4 into this is 2, right? X squared, then minus 1 over 2. So which is something I say 1 over 2 into 3x squared minus 1. So we have gotten our P2 to be what? 1 over 2 into 3x squared minus 1. Okay? So let's get our P3. I think I'm going to stop at P3. And then we'll try to use the recurrence formula to get it and see if it will work as well. Okay? So let's clean and get our P3. I hope I'm not too fast, though. Please. I hope I'm not too fast. I don't want to be too fast. All right, P3. Our P3 simply means anywhere we see and we put 3. So that is 1 over 2 raised to power 3, 3 factorial. I'm having the third derivative with respect to x of x squared minus 1 cubed. So this is going to be 1 over 2 raised to power, this is 8. 8 times 3 factorial is 3 times 2 times 1. So 8 times 6 is what? Use your calculator. Z48. I don't know. So try it. Let me pause and get calculator big. Okay, sorry about that. Since my greatest problem in mathematics is all these small multiplications. Since calculator came out, I don't want to stress myself. I must punch it in calculator to be very correct. If not, I will make mistake. I don't know about you. So multiplication of this gave us 48. Imagine I had to pause the video and go and look for calculator, and I couldn't find it, so I'm using my phone as my calculator. So now let's do the first derivative. So here we now reduce to squared the x squared. So the first derivative, don't forget, differentiate the inside. You have what? 2x. Differentiate something that has power. You multiply by the power, and then you remove one from the power. Okay? So for you not to make mistake, we're going to clear everything here. So this is going to be 1 over 48 d squared over the x squared. This time this will give you 6x into square the first one, you have x raised to power 4. Multiply the first one and the second one, double it, you have 2x squared. Square the last one, you have 1. Okay, so if you open it, you're going to have 1 over 48 the squared over the x squared. I don't want to start doing product rule here. It will take my time. So this time this will give you 6x raised to power 5 minus 12x raised to power 3, then plus 6x. I hope I'm correct. 6, 5, 12, 3, and yeah. So the second derivative here, if I bring out my 1 over 48 that is here, I have d over the x. The second derivative is 30. So I have 30 x raised to power 4, 48, right? 3 times 36. Minus 36x squared. Multiply by the power, remove one from the power, then I have plus 6. So the final one will now be keeping your 1 over 48. 1 over 48. So the final one will now be multiplied by this. I have 120 x raised to power 3. This one will now give you minus, please permit me to use my calculator. 36 times 2. Okay, 72. So I have 72x. Then this one is gone, I believe. Okay, so now 120 divided by this. 120 divided by 48. So I'm having 2.5. And 2.5 is 25 over 10, which is 5 over 2. Okay, so this one is giving us, this time this is giving us 5 over 2x cubed minus, so we have 72 divided by 48. 72 divided by 48. 1.5. 1.5 is 3 over 2. So 3 over 2x. Okay? So that is that. So our P3 is equal to 5 over 2x cubed minus 3 over 2x. Okay? So that is that. So you can try the P4, P the rest of them and get them. Okay? So that is that. So using the recurrence formula, let's try if we can get the answer using the recurrence formula. If the answer will be the same thing. So let us use the recurrence formula. The recurrence formula for Legendre says, recurrence for Legendre, where is it? Okay, recurrence for Legendre said n plus 1 p n plus 1 of x, okay, is equal to 2n plus 1 x p naught of x minus n p n minus 1 of x. Okay, so we know the two. We know that this one, p naught is always 1 and p1 is x. We already know this one. So to get from 2 and above is when we use the recurrence formula. Please note that. We don't use the recurrence formula we use the recurrence formula when n is greater than or equal to 2. Please note that. Yes, we only use recurrence formula when n is greater than or equal to 2. So let us put it here. We have that to get our p2 means that we are setting n plus 1 to be equal to 2, which means that n will now be equal to 1. Okay, so to get our p2 here, so you say 1 plus 1 here is 2, so I'm having 2p2 of x is equal to 2 times 1 is 2 plus 1 is 3, right? 3x, so I have 3x. P naught of x is 1, okay? Minus, our n is 1, then p, 1 minus 1, sorry. How did I get p? Sorry, pn, not p naught, pn. So let's go again, sorry. So this is, when n is 1, 1 plus 1 is 2, 2p2 of x, 2 times 1 is 2, plus 1 is 3. So I have 3x into my pn of x is squared. So it's x. That is p1 now. N becomes 1, and p1 is x. So I have my x minus n is 1. 1 minus 1 is 0. So I'm having 1 because it's p naught of x, and p naught of x is 1. So if you look at this, you see that if you divide both sides by 2, you have that p2 of x is giving me, this time this will give you 3x squared over 2 minus 1 over 2. So which will give you 1 over 2 into 3x squared minus 1. You see, it gave us exactly the same answer here. So use the recurrence formula to test to get your p3 of x. Okay, use the recurrence formula to get it and check if it is the same thing. I do it first before I solve it. Try it first before I solve it. And tell me the answer in the comment section. So pause the video and solve it. So for me to get P3 means I'm setting n plus 1 to be equal to 3. So we are setting n plus 1 to be equal to 3, which means that n will now be 2. So 2 plus 1 is 3. So I have 3 P3 of x, okay, is equal to, remember, 2 times 2, 4 plus 1 is 5. So I have 5x into P2 of x. And P2 of x gave us 1 over 2 into, in fact, it gave us 3 over 2x squared minus 1 over 2. Don't forget, it gave us this, okay? Minus, our n is 2. Then 2 minus 1 is P1 of x. And P1 of x is x, okay? So if we do that, I have P3 of x is equal to 5 times this will give you 3 times 5 is 15. So I have 15 over 2 x raised to power 3 minus 3. In fact, okay, 15 over 2 x raised to power 3 minus 3 times 5 is what? 5x over 2 minus 2x over 1. So I can add these two. So I have 3p3 of x is equal to 15 over 2 s cubed minus 3 times this is 6. That is 4 plus, it's 4. 4 plus this is 9. So 9x over 2. So if I divide everybody by 3, I'm going to have that p3 of x will now be equal to, divide 15 by 3, I have 5. 5 over 2 s cubed. Divide this by 3, I have 3. 3 over 2x. Is it the same thing? Exactly the same thing. So this recurrence formula can help you to get your P4, P5, P6. If you don't know how to follow that derivation method, differentiation method, okay? So let us now solve one example to this, and then I think we call it a day. Okay. So an example. Did I just clean that? Let me write it again. P1, P0 is 1. P1 is x. P2 is 1 over 2 into x squared minus x, right? Where is it? P2. Wait. Sorry about that. Let me write it again. So our P2, where is our P2? Okay, 1 over 2. This is 1 here. Okay, and then P3 is equal to 1 over 2 again into 5x cubed minus 3x. Okay, so we have this. Now, if you notice that all your P0 shows that x raised to power 0, the derivative. P1, like I told you, P1, x raised to power 1, the degree of the polynomial. P2, the degree of the polynomial is squared. P3, the degree of the polynomial is cubed. So you notice that, okay? So take note of that. So let's solve an example. And the example I'm going to solve is the question the lecturer gave us in class the day he taught us this. So let me write out the question. I think he said we should expand. Sorry, 1 minute. They say approximate approximate f of x, which is equal to exponential x, using legendary polynomial, with the interval of -1 to 1. Okay? So now, to solve this is very simple. Don't forget what we are supposed to do here. The first thing we're going to do is to write out how it will look like. Remember, it's going to look like our y. It's going to look like our y, and our y is always what? A naught. I told you in legendary we're using p. So instead of file, I'm using p. So it's going to be a naught. In fact, you write it first like the summation of I starting from 0 to n of what? A I p I of x. So this is going to be what? A naught p naught of x plus a1 p1 of x plus a2 p2 of x plus dot 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 plus an pn of x. Okay? Now, the only thing here is that he did not tell us the degree of polynomial. He did not tell us. Okay? I think if you want to approximate it to quadratic, means degree 2. They can tell you to approximate it to quadratic or to linear. If they say to linear, it means it's just degree 1. We're using just p naught and p1. So if they say degree 2 or polynomial, you're using p1, p naught, p1 and p2. If they say quadratic, if they say cubic, in quadratic is 2. If they say cubic, you are using 1, 2, 3, and so on and so forth. So in this case, I'm going to do for 1, 2. Or let me do for 1, 2, 3. Okay, let me do for 1, 2, 3, since we have from P naught to this. So to do the 1, 2, 3, that means I'm stopping at the third one. The other one is not needed. So I'm stopping at the third one. So I'm going to stop at P3, A3, P3 of x. Okay? So now, obviously, I told you that our P naught, P1, P2, P3 are not problems. We have gotten them already. So the only problem now is for us to get our A naught, A1, A2, and A3. So that is that. So for us to get, don't forget that our an is equal to what? The integration from a to b of f of x pn of x with the weight function dx all over the integral from a to b again of pn of x with squared, or you can say all squared so that it will not confuse you, weight function, then dx. Once you know this thing, you are good to go. So from this, we can get our a naught. So our a naught shows that anywhere we see n, we put what? 0. So if we put 0, I'm going to have the integral. The interval they gave us is from -1 to 1. So from -1 to 1 of what? The f of x is exponential x. So exponential x multiplied by the weight function of Legendre. Don't forget is 1. It does not change. So the weight function of Legendre is 1. So I'm looking for, and then our p naught. So p naught, then weight function is 1 multiplied by the weight function 1 dx all over the integral again -1 to 1 of exponential, of our this one, which is p naught again all squared multiplied by weight function 1 dx. So if you do this, you are going to have this is exponential x here. So p1 of x is 1. We got it. P naught of x is 1. So this is now the integral from -1 to 1 of exponential x. This is 1. This is 1. So I'm left with just the x here all over. This is 1. 1 squared is 1. So I'm just left with integral from -1 to 1 of the x. So if I do this, you see that I'm going to get the integration of exponential is still exponential. Exponential x, the boundary from -1 to 1. The integration of this, integration will cancel differentiation. I'm left with x. So x with our boundary of what? 1 from -1 to 1. So if you do this, you're going to get that a naught is equal to, where did I solve it? I don't want to waste much time. So to do this one, I'm going to have exponential 1 minus the upper bound, the lower bound exponential minus 1 all over. This one is just 1 minus minus 1, 1 minus minus 1. So what you give is just 1 over 2 into exponential 1 minus exponential minus 1. So that is what our P naught gave us. Okay? So let's get our P2. So if you get your P2, that's our A naught, sorry. That's our A naught. Our A naught. So to get our A1, we do the same thing. So let's get our A1. I think to get A2 will not be an assignment for you. It's not difficult to get. So to get our A1 is now the integral from minus 1 to 1 of f of x. F of x is what? Exponential x. We have P1 of what? Of x. Weight function is always 1, does not change. The x all over the same thing again. Minus 1 to 1. P1 of x all squared multiplied by weight function 1 dx. So which will give us the integral from what? Minus 1 to 1 of what am I having? Exponential x multiplied by, this one gave us x, multiplied by x, the x, all over the integral again of minus 1 to 1 x squared. So x squared dx. So now, if you look at that one above, you see that that one above is integration by parts. So we have to do the integration by parts. So if we do this integration by parts, I have this is the integral from minus 1 to 1 of x exponential x dx. So integration by parts say that, let's call this one, use ladies like pet, like this. So watch my video on integration to understand it. Ladies like pet means that is how to choose your u, because the formula said the integral of u dv is equal to what? uv minus the integral of v du. So we choose our u using ladies like pet. Ladies like pet means that if logarithm is there, logarithm must be my u first before polynomial, before exponential, before trigonometry. So we have a polynomial and exponential. So polynomial must come first before exponential. Okay, so polynomial is my u. So from here, x is a polynomial. So my u is equal to x. So dv will now be equal to exponential x. So to get du is to differentiate this. So du is equal to 1. To get v is to integrate this. V is now the integrate of this is the same thing. So you now write out the formula. The formula said that what? The integral of u dv is equal to what? uv minus integral of v du. Okay, so if you now put it u and v, which is what? X exponential x minus the integral of v du. So this time this is still exponential x. Okay, don't forget the boundary. The boundary is always the x. The boundary is always from minus 1 to 1. So if you do that, you're going to see that this is x exponential x minus integration of this is still exponential x. So you put your boundary minus 1 to 1. So which will give us, if I put 1, okay, which will give us exponential x in bracket of x minus 1, right? So you put your boundary minus 1 to 1. So if I put when it is 1 minus 1, I'm having 0 minus, when it is minus 1, I'm going to have minus 1 will give you minus 2. So minus into minus 2 exponential x. Sorry, exponential minus 1. So if you open the bracket, you see that you are getting minus 2 exponential minus 1. Okay? Minus 2 exponential minus 1. Minus 2 exponential minus 1. Which is giving us, is it minus or plus? This time this is plus, sorry. Just exponential minus 1, which is what? 2 over e. 2 over e. I hope it's not difficult to get 2 over e. That is for the numerator. Don't forget we have the denominator. So for the denominator, I have x squared minus 1 to 1, which will give us the x, which will give us 1 over 3 x is power 3 minus 1 to 1. So if I put 1, I have 1 over 3 minus, if I put minus 1, I have minus 1 over 3 again. So which will give you 2 over 3. So 2 over 3 times 2 over e, because, okay, divided by 2 over e, right? Because the numerator gave me, I don't know if you are getting the way I'm solving it, scattered like this. The numerator is this one, which gave us 2 over e. divided by, the denominator is this one that gave us 2 over 3, which is what? 2 over e times 3 over 2. So 2 take care of 2. You see that my P1 is now giving me 3 over e. Okay, 3 over e. So you can now get do your P3 and tell me the answer in the comment section. So with this, remember that when I got my P, I've cleaned that self. I think when I get P0, it was 1 over e. I cannot remember. P1, 3 over e. So you can just, the answer will now be, so there's the expansion we are looking for, which is our y. The approximation we are looking for, which is our y, will now be equal to, but don't forget it is a naught p naught of x plus a1 p1 of x plus a2 p2 of x. That is if we are ending in degree 2. Okay, if we're ending in degree 2. If we're ending in degree 2. So if you do your A2, our A2 gave us, from my own, it gave me 5 over 4 into 2e minus 14 over e. So check your own. So the next thing now is just to substitute. We know our x, our p of x is 1. So 1 times this, I'm having 1 over e plus this one, that is 3 over e. This one gave us x, right? Plus this one, which is 5 over 4 into 2e minus 14 over e. Then in bracket of that one gave us 1 over 2 into s squared minus 1. Don't forget. So if you want to get to the third one, so do your third one. So this time this will give you 1 over e plus 3 over ex plus this time this will give you 5 over 8 into 2e minus 14 over e, okay, over e, right? I don't know, do your own. So then into x squared minus 1. So you can now, it's either you leave it like this or you will now get the value of exponential. You know the value of exponential and then put it here. That becomes your expansion of this, the approximation of e raised power x. That becomes the approximation of e raised power x. Okay? So thank you. And don't forget to like the video, share to your friends, and drop your comments. Yes, always drop your comments. It's very important. Tell us where you don't understand, and then, or tell us a particular video you want us to do. We will do that. Please appreciate us by that your like and comment. Very important. Bye-bye.